Good evening, Javian.
Good evening, sir.
How is your preparation, Javian?
Sir, it is going good, sir.
Okay. So when you're having exam, actually,
Yes, sir.
when you're having exam,
I have one exam on second, which is my boards, and then
okay,
there is one on May 12th. That
May
is
12th,
my thing, AMECET.
MECT. Okay,
Yes,
okay,
sir.
okay. May 12th, you are
And
having
then there
a
is yes, sir. And then in the following week I have my Comet exam.
Comet exam.
Yes, sir.
Okay, okay, okay. When it is actually Comet exam, I forgot the date.
I think so. Comet K is around first or
May
second
only,
week
na?
of May. May
Ah,
only so.
May only. Yeah, yes. Because of some
I
of
think I
hmm.
think so. It is on 12th. Yeah, yeah. Sorry, 12th is Comet K, and then around 20th is the thing AMECET.
Okay, okay, okay. Then so prepare well. Okay, so prepare well for your examination. And
Yes, sir.
in last class so anyway all joined. So actually sorry for everyone because of today I didn't post class timings. So due to some busy continuous classes are there for me. So that's why I forgot to post the in group. Okay. So anyway, all are joined except one member. Samhita J is not yet joined. Right? So remaining all. So good evening all. So next we are going for the previous class. So in previous class we studied about the solutions. Okay, so solution is we are talking about the binary solution. What is the concept we are having in the 12th standard means here? So we have a binary solution. What is the binary solution means? The solution which contains the two components is called as a binary solution. What are the two components means? One is called as a solute, another one is called as a solvent. Okay, so based on the solute and solvent, solutions are classified into 9 types. Total how many types it is classified here? Total 9 types. The types of the solutions also yesterday we discussed. Is that clear? Okay, so sometimes whether in Comet K or something, sometimes they're asking the question based on the tabular column also. So because of they'll give one example. They'll give one example. Okay, so based on that example, you have to find out whether the given example is related to which kind of solution. Okay, related to which type of solution that you have to find. That kind of questions also it is that. Okay, next here. So solubility. So what is meant by the solubility? Any one of you? Next here, solubility. What is meant by the solubility? Solubility is nothing but the maximum amount of solute, maximum amount of solute, amount of solute dissolved in maximum amount of solute dissolved in solvent. Dissolved in solvent is called as a solubility. So what is meant by the solubility, ma? Solubility is nothing but maximum amount of the solute dissolved in a solvent is called as a solubility. Okay, so based on solubility of the solute in the solvent, we are considering it as a concentration also. Okay, based on the solubility of the solute in a solvent, that is also we can call as a concentration. Okay, so we already seen some of the concentration terms. So what are the concentration terms we had seen? What is the main important concentration terms we had seen? So what are the main important concentration terms we had seen means here? One is molarity, second one is molality, mole fraction, and normality. Okay, so normality. So here and formality also it is that, but generally we can consider molality, mole fraction, and normality. So all these concentration terms are very important for in this chapter also. Okay, now we got the clarity. So already we had seen, and I gave the I gave the formulas also. Okay, and I give one test. So based on this concept also, we have some questions. Generally, if you go for the NEET and JEE, also sometimes they're asking the question. Especially they're concentrating the mainly molarity and normality based questions they're asking. In examination also they're asking here molarity and normality based question. Anyway, already we discussed here. I don't want to revise once again. If you want to check it out, means better to go through the some basic concepts of chemistry concept. Okay, so in that one clearly we explain all the formulas. What are the types of formula? What are the different formulas also we are using for the calculation of the molarity and at all also. Okay, next. But anyway, shall at least we can discuss about the definition now. What is meant by the molarity, ma? Any one of you? What is meant by the molarity?
Number of moles of solute per 1 liter of solution.
Very good, ma'am. Number of moles of solute present in 1 liter of solution is called as a molarity. And what is meant by the molality? So molality is nothing but number of moles of solute present in 1 kg of solvent is called as a molality. And what is meant by the normality means here number of moles of solute, number of equivalent weight of the solute present in 1 liter of solution is called as a normality. And what is meant by the mole fraction? Mole fraction is nothing but so number of moles of components, number of moles of one component by total number of moles of components present in a solution is called as here mole fraction. So what is meant by the mole fraction, ma? Mole fraction is nothing but number of moles of one component by total number of moles of components present in a solution is called as a mole fraction. Okay, now so here next based on that one we can discuss about the solubility. So we have a different type. What is the solubility means here? So we have a solute is solid also it is there, liquid also it is there, and gases also it is there. Okay, but all are equal. They all are not equally soluble in a solvent now. Okay, so they are soluble in different ways here. So that we are going to be check it out. In that one, the first one means the solubility of the solids in a liquids. The solubility of solids in liquids. Sir, what are the factors affecting the solubility of the solids in a liquids means here? First one, solubility of the solids in a liquids is depends upon the nature of the solute. Okay, it depends upon here nature of solute. Okay, this depends upon here nature of solute. So because of we have a different types of the solids are there. What are the different types of the solids are there for us here? We have a ionic solids. One is ionic solids. One is ionic solids. Ionic solids. Second one is covalent solids. Second one is here covalent solids. Okay, so we have a different types of the solids. In that one is ionic solids, and second one is covalent solids. Okay, here ionic solids. Ionic solids are highly soluble in polar solvents. Ionic solids are highly soluble. They are highly soluble in polar solvents. Polar solvents. Okay, and covalent compounds are highly soluble in non-polar solvents. Highly soluble in non-polar solvents. Non-polar solvents. So what is the best example for that one means here? In this one, so once you check it out. So what is the example of the polar solvents? What are the examples of the polar solvents? Vedika. Vedika, hi.
Hello, sir.
Hello. So you're going to continue in this class?
Yes,
Okay, then fine. Sorry, I'm unable to take the classes for you. Okay.
it's fine, sir.
Okay, so I got a little bit busy schedule. That's why I'm unable to take here. So anyway, just now only I started the solutions chapter. Okay, so anyway, thanks for coming. Right?
Yes, sir.
So it's a 12th standard chapter we are going to be discussing here. Just now only I started. Okay, ma?
Okay, sir.
Okay, right. Okay. Now, let's see. So what are the examples of the ionic solids, ma? What are the examples of the polar solvents? Sorry. What are the examples of the polar solvents? Any one of you? Ma. So polar is nothing but if the electronegativity difference is more in between two atoms, means that we can call as a polar solvents. Okay. Now let us see in this one. So what are the examples of the polar solvents? Means water molecule, ammonia, NH3, and lower alcohols. Okay, so which one means here? Lower alcohols. So what we are going to discuss here? Lower alcohol. That means C2H5OH. C2H5OH also it acts as a polar solvent to be. Okay, and this also we can call as a polar protic solvent. Okay, so this also we can call as a polar protic solvent. They releases the H plus ions. The solvents which they releases the H plus ions are called as here polar protic solvents. Okay, sir, what is the example for the ionic solids? Means here we have a different types of the ionic solid. What is the best example which we are seeing in a daily life? Means NaCl. NaCl is called as a table salt. Is table salt is highly soluble in water or not? Is table
Yes,
salt?
sir.
Yes, sir.
Okay. My question is here I had given NaCl and glucose. That means sugar I had given. Sugar. Okay. So NaCl also I had given and sugar also I had given. So which one is highly soluble in water and which one is partially soluble in a water? You can try at home also. You can check it out and you can tell me, no problem. Either NaCl is going to be soluble fastly or sugar is going to be dissolved fastly.
So it is NaCl, no?
NaCl. NaCl is going to be dissolved very fastly while comparing with the sugar. Okay, so because of ionic compound. Okay, so because of here, NaCl is the ionic compound. Okay, so and that is also what we can say means here water, it has a high dielectric constant value. It has high dielectric constant value. Dielectric constant value. Okay, so water is having high dielectric constant value. So due to that, what is the high dielectric constant value, ma? Have listened the word of the dielectric constant? Okay, so what is the dielectric constant means here? The solvent which has high ability to dissociate the compound into ions is called as a dielectric constant. Okay, the solvent which has high tendency to dissociate the compound into ions is called as a dielectric constant. According to that one, which is having the high dielectric constant value means water. That's why water is called as a universal solvent. Okay, so why we are calling as a water is the universal solvent means here most of the compounds are there soluble in a water. Is they soluble in water or not? They're soluble in water only now. So most of the compounds are there soluble in a water. That's why water is called as a universal solvent. Okay, so solubility of the solids in liquids is depends upon the nature of the solute and covalent compound. Now in this one more question is NaCl and sugar. So which one is the ionic compound and which one is the covalent compound?
NaCl is ionic and sugar is covalent.
Covalent, very good, ma. So what is the molecular formula of the sugar? What is the component it is present in a sugar means here? Sucrose. What is the molecular formula of the sugar, sucrose? C12H22O11. What is the molecular formula of the sucrose means here? C12H22O11. Okay, C12H22O11 is the sucrose. Sucrose is hydrocarbon. Hydrocarbons are covalent in nature. But everyone you may get that down. So downside covalent compounds are highly soluble in non-polar solvent. What are the examples of the non-polar solvents means here? One is the benzene. Okay, benzene. Another one is so one is the benzene, toluene.
Sir, non-polar means they cannot dissolve into its ions, right?
Non-polar
Means it cannot dissolve into its respective ions.
Yes, ma'am. It does not dissociate. Ions cannot form in non-polar solvents here. Okay. Carbon tetrachloride, carbon disulfide, all these are the examples of non-polar solvents. Okay. Now, actually, benzene is dissolved in a toluene. Benzene is going to be dissolved in a toluene. Toluene and benzenes are dissolved in a carbon tetrachloride. Okay. And sir, benzene, toluene are they dissolved in a carbon disulfide. Sir, why you are telling all these things? What is the known example? What is the known example means here? My best example for the hydrocarbons is oils. Oils. Okay. And grease. Okay. So if any grease marks are there on your cloth, how you are going to be removed, ma? Is oils are dissolved in a water?
No, sir.
I'll ask one more thing here. I think so everyone you had seen petrol. Everyone you know about you know the petrol, diesel, kerosene. You know or you don't know? Okay. Now my question is petrol, diesel are dissolving in a water?
No, sir.
Okay, they won't be soluble here. So because of petrol, diesel, kerosenes are we can call as a hydrocarbons. All those are we can call as a covalent compounds. So covalent compounds are insoluble in a water, but petrol we can dissolve in a diesel. It is going to be dissolved in diesel or not? Petrol.
Yes, like I've not tried doing it.
Yes, actually, diesel price is very less. To be frank, I'm telling that outside somebody they're selling petrol and it all means here that is mixed with some diesel or kerosene. Pure petrol we can get as a petrol bunks only. Okay, even we can't sure. Even petrol bunks also sometimes they may be mixed with the either diesel or kerosene. Sir, why you are telling like that means petrol cost is more, diesel cost is less.
The
Okay.
petrol cost is like somewhere around 100 or something, and diesel is somewhere around in 80s or 90s.
80s, 90s. Now, my question is, if 8 liters of the, if you take some 6 liters, if you take some 6 liters of the petrol, in that one, if you add 3 liters of the diesel, 3 liters of the diesel. So total amount around how much you got as here? 8 liters na? Okay, or you can add as a 4 liters also. Okay, 4 to 5 liters also if you add means we can't find out the difference. It gives us a uniform solution and you'll be color, it will be same only. Okay, and it gives petrol is it gives us a some dense smell, but diesel it does not give that much of smell here. Okay, so if you after mixing that also if they give means that we can consider it as a petrol only, we can't find out the diesel because of there is no separate layer. It is not forming any separate layer. Okay, it is not forming any separate layer. So that's why it is not possible to identify. It is not possible to identify. So that's why what I'm telling that means covalent compounds are they're soluble in non-polar solvents only. Okay, and I'm asking oil marks, grease marks, and that all. Sir, how you are going to be removed means here. So first you are washing with the cloths with the soap. Okay, if you're washing with the water means it won't be goma. For that one, what we are doing to remove the grease marks and that all, we are giving as a dry cleaning process. In dry cleaning process, what they are using means here, they are using some non-polar solvent. If they place some non-polar solvents and they rub means immediately they can go. Okay, so because of covalent compounds are they're highly soluble in a non-polar solvents. Now you got the clarity? Okay, here, what is the another doubt means, sir, that sucrose also covalent compound, but why it is highly soluble in a water? That is question. Sucrose also it is a covalent, not only sucrose, glucose also. All of you are having glucose, summer season already started. Okay, so I think so in the evening session, everyone you may having some rasna or something, summer drinks for extra additional energy. Okay, that is also they contain the glucose content. Glucose also it is a covalent compound. Sucrose also it is a covalent compound. Okay, but glucose, sucrose are both are solids only, but they are highly soluble in a water. So why they are highly soluble in a water means because of they form as a hydrogen bonds. Number of hydrogen bonds are increases. Their solubility also is going to be increases. Okay, number of hydrogen bonds are increases. Their solubility also is going to be increases. Due to that reason only glucose, sucrose and all they are highly soluble in a water. Now you got the clarity? Everyone?
Yes, sir.
Okay.
Yes, sir.
And one more small concept it is that one. Well, coming to the inorganic chemistry, we have some salts. Okay. So what is the salts means here? NaCl, KNO3. Okay. NaCl, KNO3. Some salts are partially soluble in a water. NaNO3, KNO3 are they're partially soluble in a water. Sir, how you know about this one means here? So this one based on the experiment we can know here. You all are going to do the solubility test in the laboratory. That time we know here. They're partially soluble in a water. Of course, they are ionic compounds only. Okay, of course, they are here ionic compounds only. In that also some compounds are partially soluble in a water. Partially means they slowly they dissolve in a water. Like sugar. Sugar also is dissolved slowly only now. So like sugar here, NaNO3 and KNO3 also they are soluble in a water. To increase the solubility, we are increasing the temperature. Okay. Now in the preparation of the gulab jamun syrup, what we are doing? Either gulab jamun syrup or jalebi or something. Okay. So first what we are doing that dipping in a sugar syrup only na gulab jamuns or something. But how they are preparing as a gulab jamun syrup? Okay, they're taking as a less water, they're keeping as a more sugar. Okay, more sugar is placed in the less amount of the water, and they keep on heating continuously means whatever the excess of sugar it is there, that is also it is going to be soluble in a water. Then only it becomes as a sugar solution. So the solubility of the solids in a liquids also depends upon the temperature. Some solids are by increasing of the temperature, their solubility also is going to be increases. Some solids are there. Okay, so what are the examples with sodium nitrate and potassium nitrate? By increasing of the temperature, their solubility also is going to be decreases. Okay, now you got the clarity, ma? Clear? So nature of the solute one it is there, nature of the solvent one it is there. Okay, and temperature. So temperature also it is going to be affects. Okay, some solids are highly soluble at high temperature. Some solids are they're highly soluble at low temperature. Sir, what is the example for the solubility at low temperature means NaCl? At room temperature only it is highly soluble in a water. And sugar is there. Sugar is highly soluble at high temperature. Got the clarity or not?
Yes, sir.
Okay, right. So then we'll go for the next concept. What is another concept we are having means here? Solubility of the liquids in liquids. Solubility of the liquids in liquids. It is very simple concept. Solubility of liquids in liquids. Okay, so here also same concept. Ionic compound, polar solvents and non-polar solvents are there. Okay, for example, alcohol and water. Alcohol plus water. Alcohol is the liquid. Water also liquid. If the alcohol is highly soluble in water or less soluble in a water, ma? Is alcohol is highly soluble in a water or less soluble in a water means alcohols are highly soluble in a water. Sir, why the alcohols are highly soluble in a water means due to the formation of hydrogen bonds. Due to the formation of hydrogen bonds. Okay, due to the formation of hydrogen bonds. If the hydrogen bonds are going to be increases means their solubility also is going to be increases. Now you got the clarity. Okay, right. So next, so here some covalent compounds are there. CCl4 and all they will be insoluble in a water. Okay, so liquids and liquids also depends upon the nature of the solute and nature of the solvent. And one more important point it is that. So what is another important concept we are having means here? Solubility of the gases in a liquid. It is very, very important. Okay, solubility of gases in a liquids. Okay, so first of all, so before going to the solubility of the gases in a liquids, so which law is going to be explained? The solubility of the gases in a liquids means here Henry's law. Which law here? Henry's law is, it explains the solubility of the gases in a liquid. Okay, Henry's law is, it explains the solubility of the gases in a liquid. According to the Henry's law, at constant temperature, okay, the solubility of given mass of gas, the solubility of given mass of gas, given mass of gas is directly proportional to pressure. Directly proportional to pressure. So this mathematically how you're going to represent means here M is directly proportional to P. In this one, so M is nothing but given mass of the gas. Given mass of the gas is directly proportional to the pressure. If the pressure is going to be increases, means the solubility of the gases also is going to be increases now. Okay, if the pressure is going to be increases, means the solubility of the gases in a liquids also is going to be increases. Okay, so to remove the directly proportional, we have to write some constant value. Okay, so what is the constant we are writing means here? M is equal to KH into P. In this one, KH is nothing but Henry's constant. KH is nothing but here Henry's constant. Now you get that clarity. What is meant by the KH? KH is nothing but here Henry's constant. Okay, and so we have a one more formula also. You had taken individual here. Okay, if you had taken single gas means the solubility of the given mass of the gas is directly proportional to the pressure. But in atmospheric air, we have a single gas or mixture of gases are there. In atmospheric air, ma.
Mixture of gases.
Mixture of gases. So whenever we are having the mixture of gases means that time we have to take mole fraction. So what we have to take my here? So that time we have to take as a mole fraction. Okay. So based on that one, how we can define the statement means here. So at constant temperature, the solubility of the given mixture of gases is directly proportional to mole fraction of the component. Okay. So that is only we can write as here. P is directly proportional to X. P is directly proportional to XA, I can write. In this one, XA is nothing but mole fraction of the gas. Mole fraction of gas. Okay, so to simplify this one, how we can write? P is equal to KH into XA. Okay, P is equal to KH into XA. Okay, now, okay, so this is very, very important point here. So P is equal to KH into XA. In this one also KH is nothing but Henry's law constant only. What is meant by the KH means? KH also it is nothing but here Henry's law constant. Here we wrote as a mole fraction of the gas. Sir, how we can define the mole fraction? So mole fraction is equal to, it is the ratio of number of moles of one component by total number of components present in a solution. Total number of components means we can write as a Na plus Nb also. Okay, so XA is equal to Na by Na plus Nb. So this is the formula we are using to represent the mole fraction. Okay, is that clear? Okay, and here some limitations are there for the Henry's law also. So what are the limitations means here? As per the statement, what you are telling that at high pressure solubility of the gases, okay, are increases in liquids, but we are not taking as a very high pressure. Okay, and we can't take as a very high temperature. Okay, so temperature also is not high, pressure also we can't take as a high. Okay, and which gases we have to use means here the gases which does not undergo the dissociation, that kind of gases we are using in the solubility of the gases in a liquids. Okay, and what are the applications of the Henry's law? Okay, before going to the Henry's law, we have a one statement. So what is the main important point? It is that means here we wrote as a Henry's constant. With respect to the Henry's constant also we can explain the solubility. Okay, sir, how we can explain the solubility means here Henry's constant is inversely proportional to the solubility. Henry's constant is inversely proportional to the solubility. Okay, so that means what happened here? Inversely proportional. Inversely proportional means if the Henry's constant is very high, then what about the solubility? It is highly soluble or less soluble? Is Henry's constant is very high, ma? If it is Henry's constant is very high means, then what about the solubility of the gas? Soluble gas is highly soluble in a water or less soluble in a water? Sriyuta?
Sir, less soluble.
Less soluble. Okay, if one more question, ma. If the Henry's constant is very less, it is there. Henry's constant is less, then what about the solubility? What about the solubility of the gas?
It's more soluble.
It is highly soluble in a water. Now you got the clarity based on the KH values also. Why I'm telling that means, ma, sometimes they are giving us a KH values in the examination. They'll give us some different gases, sulfur dioxide, methane, carbon dioxide, and all they'll give. Okay, in that one, they'll ask question, which gas is highly soluble? So which gas is highly soluble means first you have to know the relationship between the KH and solubility. If you know the relationship between the KH and solubility means according to that one only we can find out the answer. Okay, so because of KH and solubility are inversely proportional. Greater the value, lesser the solubility. Smaller the value, greater the solubility. Got it, all of you? Everyone,
Yes,
you got
sir.
the clarity? Okay, right, ma. So next, so what are the applications of the Henry's law? Applications of Henry's law. So what are the applications of the Henry's law means here? So once you check it out, ma. Okay, so where we can apply the Henry's law means here, Henry's law can be used in preparation of the carbonated water and beverages. Okay, so beverages and all means we can call it as a soft drinks. Carbonated water also we can call it as a soda water. Okay, so which gas is present in a soft drinks? Everyone, you are having thumbs up, Coke, 7-Up, Pepsi. Whether you are having or not.
Yes, sir.
Okay, in that one, which gas is there, ma?
Carbon dioxide, so CO2.
Carbon dioxide gas. Okay, so which gas it is there means in that one means here carbon dioxide gas. So whenever you're opening the lid of the soft drinks, so whenever you're opening, immediately some gas comes outside with high pressure. Okay, and gas also it comes outside in the form of some bubbles which makes us some hiss sound. That is correct or not?
Yes, sir.
Okay, they'll make some sound. Why that sound is coming means here because of carbon dioxide gas is expelled into the atmospheric air. Okay, that gas it comes outside in the form of small bubbles. Then it comes outside here in the form of small bubbles. Whenever the bubbles are going to be broken means they'll give us some sound. Okay, that sound only we are going to be observe. So Henry's law is applicable in beverages. Where we are using means in the preparation of the soft drink. That means carbon dioxide is filled at high pressure in a soft drinks. Okay, carbon dioxide gas is filled at high pressure in a soft drink. And second application. So what is the second application means here? Are we seeing oxygen cylinders? Oxygen cylinders. Okay, so we are applying, we are taking as a oxygen cylinders. So actually oxygen cylinders are containing oxygen gas, nitrogen gas, and helium gas also it will be there. Okay, so helium gas also it will be there in an oxygen cylinder. Okay, so two things we are using. So two places we are using oxygen cylinders. Sir, where we are using as a oxygen cylinders means here, who are climbing Mount Everest. Okay, have you seen in news and some videos also we are seeing in National Geography channel or something. Okay, BBC News and all. Every year, that is also some nowadays it become as a big event. Okay, anyone they can apply for that. But first they'll give us some physical training they can give. Okay, so not everyone they cannot climb that one because of some stamina is required to climb the Mount Everest. Okay, so who are climbing Mount Everest? They are carrying as an oxygen cylinder. First, my question is, why they have to carry the oxygen cylinders, ma? Why they have to?
Because there's less.
Because
Javian, you're giving some answer.
so because like there's less oxygen levels, the higher you climb, the oxygen levels reduce there. So we need to carry the oxygen cylinder.
Very good. Okay, so whenever at high altitude, if the height is going to be increases, means atmospheric pressure is going to be decreases. Okay, at height is high altitudes, what happen? My height is going to be increases, means atmospheric pressure is going to be decreases. Okay, at atmospheric pressure only, oxygen gas is highly soluble in a blood. Okay, so without oxygen cylinders, whenever you are climbing the Mount Everest, means in atmospheric air, oxygen is there, but it is not dissolved in a blood because of we have a low pressure. At low pressure, oxygen is insoluble in a water, in a blood. Okay, so whenever oxygen levels are decreases in a blood, means here slowly we are losing some thinking ability. Okay, slowly we are losing thinking ability. So losing of thinking ability only we called as a anoxia. So what is the disease name, ma? So what is the name of the disease means here? So losing of thinking ability is called as here anoxia. Okay, so when you will get, where you will get means here at high altitudes, if the oxygen levels are low in blood, so that time, so losing of we are losing thinking ability. Losing of thinking ability only we can call as a anoxia. To overcome that one, we are using as an oxygen cylinder. We may get that out. Sir, oxygen gas is there, nitrogen is there, and helium also it is there. Oxygen is going to be dissolved in a blood. Then what about the nitrogen and helium? Why we are taking as a mixture of nitrogen, helium, and oxygen in an oxygen cylinder? What is the reason? What is the reason? So here, what is the reason means all these three gases are chemically does not react. Chemically, they does not react here. Okay, oxygen, nitrogen, okay, oxygen, nitrogen, helium are chemically they does not react. Chemically, they does not react. That is the first point. And what is the second point? Why we have to take the mixture of gases means to increase the internal pressure of the gas, because of gases are already everyone knows here kinetic molecular theory of the gases. Okay, so when the gases molecules are they collide with one another, means the internal pressure of the cylinder is going to be increases. If the internal pressure is going to be increases, means gases are expelled, it comes outside. Okay, whenever the gases are comes outside, oxygen is going to be dissolved in a blood. Then helium is not reacting with blood. Helium is inert, ma. Helium is inert. It does not react with hemoglobin. So why we are adding as a helium gas means to increase the internal pressure of the gas. To increase internal pressure of the gas. And whatever the nitrogen we are taking also, that it is expelled into the atmospheric air in the respiration process. Okay, whatever the nitrogen gas we are taking here, that is also it is expelled into the atmospheric air in a respiration process. Okay, and deep sea divers also they are using as a oxygen cylinders. Deep sea divers also they are using as a oxygen cylinders. Okay, so what are the deep sea divers? Okay, and why they're using as oxygen cylinders means in deep sea also pressure is very less. Pressure is very less. Okay, so to overcome that one, they won't get us oxygen in that place. So to overcome that one, they are also using as oxygen cylinder. But in this one, we have some disadvantage. Sir, what means here? Now we are not in the atmospheric air to release the nitrogen gas, to expel the nitrogen gas, but we are in water. Okay, we can't release the gases. If whenever you can't release the gases means in blood, nitrogen content is going to be increases. If the nitrogen content is going to be increases means it causes bends. What it causes my here? It causes bends. Sir, what is meant by the bends? What is meant by the bends? Bend is nothing but it causes a giant pains. Okay, so nitrogen is going to be deposited at joints, bone joints are there. At that place, it is going to be deposited. That time, we can't fold our finger, we can't fold our hand or something. It causes some joint pains. Causing of the joint pains only we can call as a bends. Okay, so to overcome that one only, how much swimmers also, they used to come outside surface of the water at least once. Okay, after some time they used to come outside. Why they used to come outside means to expel the nitrogen gas into the atmospheric air. Until here clear, all of you? So what are the applications of the Henry's law means here? Henry's law can be used in the beverages, and at Mount Everest climbers also they can use as oxygen cylinders. That oxygen cylinders are containing the oxygen, nitrogen, and helium. Okay, deep sea divers also they can use as a oxygen cylinders. Now we got the clarity, ma, all of you. Okay.
Yes, sir.
Until here you understood now, and some simple points I can ask here. So what are the factors affecting the solubility of the gas? Two points only. What are the solubility of the gases? Okay, what are the solubility of the gas in a liquids? Okay, so what are the factors affecting the solubility of the gases in a liquids? What are the factors means? First one is pressure. Already we had seen now only. If the pressure is going to be increases, solubility also is going to be increases. But there is no effect of the pressure in a solubility of the solids in a liquids. There is no effect of the pressure on solubility of the solids in a liquids. So where it is going to be effects means here, pressure is affects only in the solubility of the gases in a liquids. Now you got the clarity. And another one. So what is the another one means here? So nature of the gas. Nature of gas. So we have different types of the gases are there. The gas which is easily soluble. The gas which is easily soluble. Easily soluble. The gas which is easily soluble or easily liquefied. Easily liquefied. The gas which is easily liquefied, that highly soluble in a water, that highly soluble in water. So now you got the clarity until here. And what about the temperature? Last one more. Temperature. So what is the effect of the temperature? So what is the effect of the temperature means here? If the temperature is increases, if the temperature is increases, solubility is decreases. Solubility is decreases. Sir, why the solubility of the gases is decreases by increasing of the temperature means here? The solubility of gases in a liquids is exothermic in nature. Solubility of gases exothermic in nature. Exothermic in nature. Okay, if the temperature is going to be increases means gases are expelled into the atmospheric air. For that one, I'll ask for a simple question. Cold water is very taste, hot water is very taste. Do you understand my question? Cold water, hot water, it is there. Which one is it looked as a tasty? And
Cold water.
cold water, very good. Okay, and soft drinks also, you're having soft drinks. When you are having soft drinks, either in cold condition or hot condition?
Cold condition.
Cold condition.
Yeah.
Okay, so because of at cold condition, gases are highly soluble in a water. Yeah, it's highly soluble in a liquid. But whenever you're increasing the temperature, so once you check it out in hot condition, once you have a soft drinks and you observe the taste, how much difference it is there. Okay, so why it is having that much of difference means in hot condition, the gases are expelled into the atmospheric air. Once the gases are expelled into the atmospheric air means it changes taste also. Okay, so generally in rainy season and at all, we are having as a boiling water. Okay, so which one removes the thirsty means cold water. How much hot water also if you have, you feel thirsty only. Is it right? Because of you are not getting sufficient amount of the oxygen. In hot water, you are not having that much of amount of the oxygen. Which one is having the high oxygen content means here, cold water is having high oxygen level. Okay, so that's why whenever you are having, you feel taste, at the same time it removes your thirsty also. Got it, all of you?
Yes,
Okay.
sir.
Okay, right, ma'am. So until here, once you check it out, based on that one, I'll try to forward some questions only. Okay, we can practice that questions, and remaining concept I'll continue tomorrow. Okay. So this is a very, very important point. That's why I'm going very slow. Exam point of view important here. Henry's law is very, very important. Okay. Right, ma'am. So thank you all.
Thank you, sir.
So welcome.
Thank you, sir.
So welcome, Javan. So we'll continue tomorrow. Okay. Bye.